Okay, students, we're now here on the second special right triangles. In this one, we're going to be talking about 30, 60, 90 triangles. So yesterday, we had all that cool stuff about 45, 45, 90s, and now we're going to talk about 30, 60, 90 triangles. All right? So, again, a lot of these are just going to be side effects of Pythagorean theorem, and we're going to learn some cool shortcut and rules. But really, to investigate a 30, 60, 90 triangle and to figure things out, this is what we're going to do. We're going to take an equilateral triangle, and we're going to go cut it in half. We killed it. All right? Now, let's focus over here. Well, it's an equilateral triangle, so that angle was 60 degrees. This is a right angle because we just cut it in half. So that's 30 degrees. All right, so let's just focus on this left portion over here. All right, now let me think, what do I want to do here? So we have the hypotenuse. Let's just make up a number. Let's pick an even number. Let's do, I guess, 10. All right. But realize in this right triangle, that's a hypotenuse, but all these side lengths are 10. I cut it in half, so this short leg, SL means short leg, is going to be 5. Because I cut it in half. And then we have this long leg over here. What's this long leg? Well, we got our good friend Pythagorean theorem where we can actually calculate the long leg. Let's just go ahead and do that right now. So let's call the long leg x. So we're going to have x squared plus the short leg, which is 5 squared, equals the hypotenuse, 10 squared. We're going to do a bunch of calculations. Oops. X squared plus 25 equals 100. X squared equals 75. X equals the square root of 75. So again, we got to simplify it. What's the largest square factor that goes into 75? That'd be 25. Radical 3. X equals 5. Radical 3. The long leg is 5. Radical 3. All right, so that's a 30, 60, 90 right there. We found a bunch of sides. Interesting stuff. There's going to be patterns. Maybe you're starting to already recognize the pattern. That's great. If not, stay tuned. All right. So given that fact, and we actually just worked out a problem, we're going to do some more. All right. So in this one right here, we're going to have the short leg. So in the one above, I gave you the hypotenuse. This is a short leg. Now remember, everything we know, you just imagine that this is a full equilateral triangle. A 30, 60, 90 is just a equilateral triangle cut in half. So hypothetically, this whole part would have been 8. So I know that x is 8. All right, so a little foreshadowing. Maybe I'm giving away the punchline a little too early. To go from the short leg to the hypotenuse, I'm multiplying by 2. Right? That's a rule, that's a relationship, that's a fact, that's a pattern that we're going to talk about the whole day today. So now we're going to find the long leg again, which is y. So we're going to have y squared plus 4 squared equals 8 squared. Y squared equals, or I keep writing equals, silly me, brain farting. Y squared plus 16 equals 64. Subtract 16 from both sides. Y squared equals 48. Take the square root of both sides. What's the largest square factor of 48? 16. What remains is radical 3. So y, the long leg, would be 4 radical 3. And again, maybe you're seeing a relationship with all these numbers between the short leg, long leg, hypotenuse, so on and so forth. All right, there's patterns. So it's a value that's 8, That was 4 radical 3. All right. So we got 3 examples here. We're going to just use brute force and use Pythagorean theorem each and every time. And by the end, hopefully, we're going to realize a pattern and we can talk about that pattern. So we have the short leg is equal to 6. So short leg to hypotenuse. This is the hypotenuse because it's opposite the right angle. It's multiplied by 2 because I cut the equilateral triangle in half. So that's 12. Let's call the long leg, we'll call it L for a long leg. L squared plus 6 squared equals 12 squared. L squared plus 36 equals 144. L squared equals 108. L equals the square root of 108. What's the largest square factor of 108? 36. Radical 3. So L equals 6 radical 3. And that was the long leg. 6 radical 3. Some massive relationships going on. I wonder what it could be. Same problem, just different numbers. We have the short leg is 10. So the hypotenuse, hopefully, boom, automatically notes 20. Now you guys might be able to say, well, I know what the long leg is. I don't even need to use Pythagorean theorem. That's great. Hopefully you're there. If not, stay tuned and find out. L squared plus 100 equals 400. L squared equals 300. L equals the square root of 300. L equals the square root of 100 times the square root of 3, or L, the long leg, equals 10 radical 3. Nice. Those are the 3 side lengths. So again, this what's so great about special right triangles, you given one side length, you can find all 3. All right. And just a typical right triangle, you need 2 of them to find the third. In a special right, you need 1, and you can find the other 2. Amazing. All right. All right. We given pesky radical 2 as the short leg. We can still easily find the hypotenuse by multiplying by 2. So the hypotenuse is 2, radical 2. And then what's the long leg? We'll find that again. We're going to be very careful with our calculations. L squared equals radical 2 squared, or L squared plus radical 2 squared equals 2 square root of 2 squared. L squared, the square root of 2 squared, just makes that 2, equals 2 squared radical 2 squared. So we're going to have to simplify this right-hand side. 4 times 2. L squared plus 2 equals 8. L squared equals 6. So L equals the square root of 6, which cannot be simplified. All right, so this one a little bit goofy, a little harder to see the pattern, but the same pattern still exists. It's good to practice a little goofy problems every now and then, really build our number sense. All right, so explain the words. All right, so X is the short leg, and I really like to call that SL. We got the hypotenuse. So in words, the hypotenuse, which I like to call hype or hypo, I'll do hype. Hype equals the short leg. Actually, let me write it like this. Equals 2 times the short leg. It just doubled it. So this would be 2x in terms of x. Then we got the long leg. All right, which I like to call LL. All right, the long leg equals the short leg times radical 3. That's it. That's the rule. All right. So when you're given the short leg, to find the hypotenuse, you double it. To find the long leg, you include a radical 3 at the end. That's it. That's all you have to do. That's not too bad. All right, we're going to practice this more in the future, but that's it for this video.